Next problem is, if a belongs to R and the roots of the equation ax square minus 3x plus c equals to 0 are two positive numbers whose difference is 2, then a equal to. Now solution. Given is the roots of the equation ax square minus 3x plus c equals to 0 are two positive numbers whose difference is 2. So we'll assume the roots of the equation ax square minus 3x plus c equals to 0 are alpha and alpha plus 2, where alpha is greater than 0. Now these are the roots, so this will satisfy the equation. So a alpha square minus 3 alpha plus c equals to 0. Similarly, alpha plus 2 also satisfy this equation. So we'll get a into alpha plus 2 whole square minus 3 into alpha plus 2 plus c equals to 0. Now we'll open this one. We'll get a into alpha square plus 4 alpha plus 4 minus 3 alpha minus 6 plus c equals to 0. So we'll get here a alpha square minus 3 alpha plus c plus 4a alpha plus 4a minus 6 equals to 0. Now given is a alpha square minus 3 alpha equals to 0, so this term will be 0. We'll get 4a alpha plus 4a minus 6 equals to 0. So from here we'll get alpha equals to 6 minus 4a divided by 4a. We know alpha is greater than 0. So we can say 6 minus 4a divided by 4a must be greater than 0. If I take minus 4 common, we'll get a minus 6 by 4 divided by 4a should be greater than 0. So if I draw wavy curve, so 0 and 6 by 4 is critical point. This side will become minus, this side plus, then minus. So we want this side should be greater than 0. So we'll take between 0 and 6 by 4. So answer is open interval 0 to 3 by 2. So a belongs to 0 to 3 by 2. This is your answer. Next problem is, let fx equals to x cube plus px square plus qx plus r, where p comma q comma r are integers. F of 0 and f of minus 1 are odd integers. Which of the following is / are correct? First option is f of 1 is an even integer. Second option is f of 1 is an odd integer. Third option is fx equals to 0 has 3 distinct integer roots. And fourth option is fx equals to 0 cannot have 3 integer roots. We'll find out solution. Fx is given x cube plus px square plus qx plus r, where p comma q comma r belongs to integer. Given is f of 0 and f of minus 1 are odd integer. So we can say f of 0 is what? R. So r is odd integer, because f of 0 is what? Odd integer. So r equals to, we can assume as 2n plus 1, where n belongs to integer. Similarly, f of minus 1. So f of minus 1 is what? Minus 1 whole cube plus p into minus 1 whole square plus q into minus 1 plus r. This will get a what? Minus 1 cube is what? Minus 1 plus p into minus 1 whole square is what? 1 only, minus q plus r. R is 2n plus 1. So this is p minus q plus 2n. Given is f of minus 1 is what? Odd. So p minus q plus 2n is odd. We know 2n is even. So p minus q must be odd. So difference of two integer is odd. That means one of them is even and other is odd. So r is odd, p and q, one is even, other is odd. So we will find out f of 1. So f of 1 is 1 plus p plus q plus r. This will get us 1 plus p plus q plus r. R is 2n plus 1. We will get us p plus q plus 2n plus 2. So 2n plus 2 is even. Out of p and q, one is even, one is odd. So one even number, one odd number, sum will be odd. So this we can say odd. So f of 1 is odd. So B option is correct. C option is given fx equals to 0 has three distinct integer roots, and D option is given fx equals 0 cannot have three integer roots. So we'll check fx equals to x cube plus px square plus qx plus r have three integer roots, that is alpha, beta and gamma. We can say alpha plus beta plus gamma equals to minus p. Similarly, alpha into beta plus beta into gamma plus gamma into alpha equal to q, and alpha beta gamma equals to minus r. Now we know r belongs to odd integer, so we can say alpha beta gamma equals to odd integer. Here we can say three integer number multiplication is odd integer, that means alpha, beta, gamma, all three must be odd. We can say here alpha is odd integer, beta is odd integer, gamma is odd integer. So we can say alpha plus beta plus gamma. So sum of three odd integer is also odd integer. So we can say p is odd integer. Similarly, we can say alpha into beta is also odd integer, plus beta into gamma is also odd integer, plus gamma into alpha also odd integer. So sum of three odd integer is also odd integer. So we can say q is odd integer. We can say roots of fx is integer if p and q both should be odd integer. We know that p and q, one is even, other is odd integer. That means p and q both should not be odd integer. That means we can say roots of fx is not integer. That means D option is correct. Next problem is if ABC are distinct real numbers such that the quadratic expression q1x equals to ax square plus bx plus c, comma q2x equals to bx square plus cx plus a, and q3x equals to cx square plus ax plus b are always non-negative, then find the number of possible integer in the range of the expression y equals to a square plus b square plus c square divided by ab plus bc plus ca. Now solution. Given is a comma b comma c are distinct real number. So we can say a is not equals to b is not equals to c. So we can say a minus b whole square plus b minus c whole square plus c minus a whole square is always greater than 0. Here we can say a square minus 2ab plus b square plus b square minus 2bc plus c square plus c square minus 2ac plus a square is greater than 0. So from here we can write 2 times a square plus 2 times b square plus 2 times c square is greater than 2ab plus bc plus ca. So from here we can say a square plus b square plus c square divided by ab plus bc plus ca is greater than 1. Here we can say y is greater than 1. Next is given quadratic expression q1x equals to ax square plus bx plus c, and q2x equals to bx square plus cx plus a, and q3x equals to cx square plus ax plus b are always non-negative. You can say ax square plus bx plus c should be greater than equals to 0 for all x belongs to R. So for this equation we can say a must be greater than 0 and b square minus 4ac should be less than equals to 0. We can say bx square plus cx plus a must be greater than equals to 0 for all x belongs to R. So for this equation we can say b must be greater than 0 and c square minus 4ab should be less than equals to 0. Same way we can say cx square plus ax plus b must be greater than equals to 0 for all x belongs to R. So for this equation we can say c must be greater than 0 and a square minus 4bc should be less than equals to 0. Now if we add these three equations we can say b square minus 4ac plus c square minus 4ab plus a square minus 4bc should be less than equals to 0. So if we simplify, we can say a square plus b square plus c square should be less than equals to 4 times ab plus bc plus ca. So we can say a square plus b square plus c square divided by ab plus bc plus ca should be less than equals to 4. This is nothing but what? Y. So we can say y should be less than equals to 4. Now from these two equations we can say y should be greater than 1 and less than equals to 4. So integer value of y is 2, 3 and 4. 3 values. This is your answer.